Hello class, Dr. Mike here. We're going to take a quick look at Linux process control and processes. So a process itself, what is a process? It is either started by the user or by the operating system, and it is basically a task, a app. Usually refers to daemon, or in Windows side you can term it as a service. They might start several processes. So you have a parent-child relationship. So you could have a parent process that starts several children. An example of that is a Apache web server of a root process that is started, and it will spawn several child processes to go ahead and handle the web traffic. So the process itself, how we see processes, how we control processes. So first off, the PS command. That is going to be your base command we're going to look at. Now, PS by itself is going to show me processes within my shell, and that's here. So my local shell, I just ran the PS command, and it showed up as a process. Now, it's no longer available now because I ran it, it sort of showed up when I ran it. And of course, my bash shell, which is running. So real common thing is PS minus E or PS minus EF. So let's go ahead and pipe that to less. There's a long list here. So there's a lot of different variations of the PS command. Definitely look at the man page, look at the help pages for PS. PS space dash EF will show you extended full format of the process tree, all the processes on the system. Now, first thing to notice, processes have IDs. I call it PID, process ID. Processes also have ownerships, just like files and directories do. In this case, this is a root-owned process, and it's process ID number 1. This is actually our kernel, systemd here running on Fedora. And you can see here, here's our threaded kernel, and we have a parent process. This is the child of 2. So everything served is becoming the child of 1. Now there's sort of a tree set up here. There's a ps tree command. You can sort of run this here, ps tree. Now, this might not be on all Linux distributions. And to be honestly, ps tree is something I never really use in the field working with Linux systems. It's a good way to sort of visualize the processes, but ps minus EF, and you'll see in a different video, piping, pipe to grep for something is usually a real common way to look for certain processes. So again, there's a separate video on piping and redirection, and so those two are going to be used here in this video. So watch that one first, and then come back to this one. So piping redirection first, and then look at process control. But back to PS tree, you can sort of see the tree structure of processes, how everything is everything is a child of the kernel, and then it itself my other children here. So PS tree, pretty anyway to sort of visualize it, and there's some options you can do with PS tree also, but in reality, PS is where we see our processes, and PS space dash EF is how we see all processes. So it's very common to take this and pipe it to grep for bash, let's say. And I can see there's a bin bash running right here. Bin bash shell. Process ID is 1303. Very important we understand the process IDs. We're going to come back to those when we look at controlling processes. So again, PS command to see the processes. Processes have a hierarchy, a parent-child relationship, and they have owners and IDs. So, it's important concepts here. Now, how does it come into play when we actually do stuff here? So, as root, you might find yourself using the PS minus EF or some variation of that to look for a specific process. Usually troubleshooting, make sure something is running or not running, or something is not taking too much CPU cycles, and that's a separate look at system resources. We dig into that, so you'll see that PS used again, as well as other commands like top to help you troubleshoot. But for basic use, if you're running something in your local shell, let's run this command called sleep. We'll do 100. You notice that it is going to hold my session until it releases it, because this is currently running. Now this could be anything. This could be a shell script, binary. This could be any long series of commands that take a while to run. You can see I'm sort of stuck now until I get my terminal back. Now yes, we are in a GUI here. I could just open a new tab and I'm good to go. But there's times you don't have a GUI. In fact, several times you're going to deal with a server. It will be a command line only, CLI interface only. In fact, the Ubuntu server here in our NetLab is that. You'll see that there's no scroll bars, there's no tabs. It's just all terminal only. So how can you get out of this? Well, Control-C will actually escape that. So if you ever get stuck, that's a great thing to look at. Control-C will help you break out of that. Now, if you run that again, but I don't want to kill it, I can do Control-Z, and that has backgrounded the process. It's called backgrounding. So now it's actually on my job list, which I use the jobs command to see. You can see it stopped. It sort of paused it for me. And I can use a command called bg, and I use the reference of it, %1, which is the index number here. And now it's running. So Control-Z sort of paused it and pushed it to the background, and gave me back my prompt. So Control-C will kill it. Control-Z will pause it and put it to the background. Now our second command here we saw is jobs. Jobs gives you the local jobs list. These are jobs only within my terminal session. I'm currently running in my bash shell session right now. This right here. So no other sessions, no other users, just my user, my shell. I can see the jobs here. See, jobs is still running, sleep job. Now I can control this several ways. I could bring it back to the foreground. I can FG, %1, and now I'm back to where I was before, which is not really a good situation, but there's times you could be running a script that has a lot of output. You background it, do something, and you put it back to the foreground so you get that feedback from the script, maybe output, verbose output logging, for example. But you need to stop it for a second to change something, then come back to it. So there's ways to do that. And you can see now it actually finished. So if I do jobs, jobs list is now clean. So the sleep command is pretty handy. You can do this in several ways to go ahead and see your jobs. So you can run several of these at one time too, and it's pretty benign. So all sleep does is just gonna do that. It's asleep. It just pauses for how long in seconds. So, and in this case, we're using this here just for the example of the lab. So, in reality, again, you might have a shell script that's running, very intensive, very long running shell script. It could be doing backups, log parsing, for example, that you need a background. So, let's say this example, I need to do that. I want to background this. I don't want to have to do the BG or Control-Z. I don't want to pause it for any reason. So again, let's do sleep 100. And I'm going to go and use this, sort of the @ symbol. It's a Shift-7 there. I want to push this to the background. And now you can see I have my prompt back. It's on the jobs list. And you can see it gave me the process ID. So I do PS, you can see 1397. 1397 is sleep. So we can see our PS list and our jobs list. Shows it sleeping. Yeah, it shows it sleep. Sleep is running. And it will run and continue till it's done. Now again, we can still control things on this list here. So let's go and clear screen off here for a second. Okay, jobs. So we can actually run several of these. So let's run some more. So I have 4 running. Let's say I want to get rid of the 4th job. Maybe it's a separate shell script, but for now, doesn't matter what it is. I need to remove this 4th job. We can issue a kill command. These are called kill signals. Now we actually saw 2 signals already. Control-Z and Control-C are actually signals that are sent from the terminal. Those keystrokes are caught and they're represented as a stop or pause. And we saw that with Control-C. it sort of stopped and killed that sleep and brought us back to the terminal. We'll control Z, which paused it and put to the background. We actually can issue a kill command. We can kill, in this case, number 4, %4. And if I enter, I sort of get a delayed reaction, but it says terminated. I do jobs. You can see now I have 3 running. So that's a quick way to go ahead and do that. Now there's other ways to kill processes. So kill command, you can see, actually look, the first one was finished already. These will start probably finishing here in a little bit. Go and spawn another one here. There we go. So 1407. So PS 1407. So let's say I want to kill 1407. Now, of course, the best way to do it is to use a kill command here. As we saw, use kill on the percent number. But let's say we're root user and we don't have access to the local shell, jobs. So let's do a new tab here. Let's become root. All right, so now if I do jobs, you can see I can't see them because those are attached to this bash shell. Let's do a few more sleeps here just to make sure we got some running in the queue here. There we go. So again, in this terminal, I can see those jobs running. As root, though, I don't see no jobs. So I do ps-ef, and I pipe to grep for sleep. I can see those right now. There they are, 1527, let's say. So I want to kill this job. So first off, again, you need to be either a root user or be the user itself that owns that job. Now, this was a sysadmin terminal. I should have access to actually alter this process. And there's several ways to lag. You'll see you can also change things like priority, but for now we're going to keep it simple. We'll look at just how can I either background or just kill this job. So we have the kill command, and we can pass in several ways. We could pass in the PID number. So if I kill 1527, I do sleep, you can see 1527 is now gone. I have 1526. In fact, if I go back to here, you can see 1527 was terminated. So let's go and start a few more of these here. Here's 1533 and 1532 now. So there's 1533 and 1532. So the best way to use is the kill command. There's several ways to use kill command. I'll show you really a simple way, and I showed you the first one already, which was kill and the PID number. So this sends what they call a sigkill command. Sigkill sort of force the process to kill. So the kill command, when used with just by itself, sort of says, hey, process number 1527 in this case, please shut down. And process will go, yes, that's fine. I close the open files, I close the open sockets, and I have shut down, cleaned out myself. That's the nicest way to go and sort of stop an app from running, or stop a process from running, is use the kill command. Now let's say you issue the kill command and it does not stop. It still keeps going. So with the kill command, we can issue, let's do another ps-ef grep here. All right, so we still got 1533. I can do a kill -9 to 1533. And that will kill it. Now if I come back here, you can notice it says terminated. Here it says killed. So that's a sig kill or dash kill or -9. There's several ways to look at that. Again, look at the command for the command page for kill. This is this really as root, this tears the rug out of any of the process. This really this closes the process. It doesn't matter what it's doing. Use this in emergencies. You know, the process is going really bad. It's causing memory to spike. It's causing CPU to exceed, to go ahead and dime out. We're talking, it's caused a lot of issues. You need to emergency kill that. So kill -9 will pull the rug underneath it. Now, if it had open files, it could cause corrupted files. If it has open sockets, it could leave sockets open. So there's some possible cleanup. If it had children process, it could leave what's called zombies. So again, that's the kill command there. -9 is a sig kill, it's like a force kill. Kill by itself sort of is a terminated, sort of shuts it down, whereas sig kill kills it. So, of course, best thing to do is if you can let it run until it's done normally, let it run its course. But again, there's ways to do that. Now, kill itself, we have a few ways we can do. There's a p kill and kill all. Kill all. Usually you can do -u and like sysadmin. If I type correctly. Now, I won't actually do this, but this will actually kill all users owned by sysadmin. Now, I don't want to do that. That's pretty drastic. But there's a kill all command you can explore, and process kill or p kill. So, now something else to consider. Let's say I have a script I need to run here. And I need to actually run it and log off. Now, if I do this again, if I do the sleep 100 and I exit the session, it should remove that. Yes, this case is still running. That's because the terminal is still running. But a lot of times if you work remotely, you want to run a job, like let's say a long process, it's very common to call it NoHop or hopping. Think of it as no hang up. And that actually comes from the old days where you would dial in with a phone. And so what you can do is you can NoHop, and then maybe whatever the script is, in this case sleep 100, and then background it. So this will actually NoHop it, and it will pass it to the background. In this case, I actually have a root job now running a sleep here. So again, NoHop means there's no chance of me removing this shell session. If I close this shell session out, this entire terminal session, it will not kill that job. That job is removed from the shell session, sort of, and it will sort of ignore the hang up or the HUP signal. So that's the HUP. Process priorities. We'll see this, and we'll probably can show you here. Look at top, and top command, TOP. We're going to come back to this later. This is sort of a live view. This looks sort of familiar if you're used to Windows. I don't go over all of it here, but really this is your process list. And on top is we have some stats of the system. Again, I won't skip these for now, but there's a priority you can do. Priorities that go from lowest of 19 to the highest of -20. And it's called a nice value. In this case, -20 here for CPU set. So it has a very high priority. You can re-nice a process or nice it when you start it. You can set a nice level of nice command. So I can set a nice level, let's say of -19. And I can do that for sleep 100. And I can background that. So again, you don't see it here, but the basic PS command. Basic PS command is only going to show me the process list, but PS minus EF should give me, or ELF minus, let's do ELF. Pipe that to less. Actually, let's do this. Script for sleep. So there we go. There's the 19. So again, we have -20 for the highest priority. Default is 0, sort of in the median, and then lowest of 19. So negative is higher priority, positive lower priority. So you can go ahead and, of course, re-nice, which is the re-nice command. You can change it if you own it or you're a root user, or you can set it upon when you run it, like I did here with the nice command. This is again, I want low priority for this 19. It can take its time. It can get pushed down for other things. So this might be for a long-running script. Maybe I'm running a lot of data analysis, maybe a Python script. I don't want to overload the system. Most of the time, to be honest, though, I leave it to the kernel. Leave the nice value, the priority, at 0. Set by default for the kernel. Let it handle its own. But again, there's an option you can do that here. So again, there's other things we'll look at in other parts of the course. The free command, memory use, and you saw top. I think the lab might cover top, it might not, but top, very handy command, Q to quit, to see your running process list. So if you're a root user and you're like, why is my system so slow? Top command, I see someone's running something that's causing a lot of issues. I'll show you an example here. Let's do this. If I cat dev 0 to dev null, and background that, if I do top now, you'll see that is taking up 95%, 98% of my CPU. So top's a great way to see who's using the most, so I can identify the process ID, who owns it, and then come back and either find that person, find that process, or I can shoot a kill command on it. So if it's an emergency. So in this case, I want to kill -9 on 1607. You can see I killed that, and now I'm back to normal stats. So anyways, lots of a top, but you can see how you integrate it, use it with the kill command and the process commands. So that should do it for process management, and have a good day.